sea simulator, or CSIM for short, is an extremely sophisticated experimental marine research facility. You know, we conduct research in aquaria on marine organisms, in particular organisms of the Great Barrier Reef. It's a $45 million facility, and we've cherry-picked the best technology from around the world. We've brought it here and put it into a package to make an amazing facility, trying to replicate the conditions that are found on the reef as closely as possible to improve the research we're conducting here. The CSIM also enables research we haven't been able to previously do. As an example of that is our multi-generational studies. We have large tanks that are replicating the conditions we currently find on the reef, conditions that we expect to find in the year 2050 and the year 2100. What we're doing in those systems is we're looking at multiple generations of corals, how those future generations are able to cope with those conditions. This is quite novel research. In the past, what we've done is we've taken organisms from today and plonked them into future conditions. We know organisms can adapt and acclimate to those conditions. We just don't know how far they can carry that. So these multi-generational studies that might take 3 to 5 years, are quite novel, but they're really important in determining how our coral reefs are going to respond to future climate scenarios.
Yeah, we have a couple of hundred research staff, but we're trying to address very large questions, and so being a small research agency, we really recognise and value the need for collaborations. And so if you look at our scientific outputs, most of them, and I mean most, you know, it's probably more than 60% are collaborative. So we collaborate nationally with other research providers, universities, CSIRO, but we recognise that Australia doesn't lead everything, and we collaborate where necessary with international researchers.
I'm a specialist in sponge ecology. So if you don't know what sponges are, they are filter feeders. At the moment, I'm here in Townsville at the sea simulator, investigating research questions surrounding the effects of sediment on the early life history stages of sponges. Sponges have different types of larvae. There are about 9 different types of sponge larvae. So the one I'm looking at the moment is called the tufted parenchyma larvae, and it looks like a bullet. So it's less than 1 millimeter long, and on one end of the larva there's a pigmented ring and also a tuft of cilia, which are long hairs. So that pigmented ring acts as an eye, so it's almost like a primitive eye, so it can detect light, and with the aid of the long flagella at the end of the larva, it can move towards or away from light. This experiment is to look at the effects of suspended sediment. So there's really fine sediment which are hundredths or even a thousandth of a millimeter, and we expose the larvae to that sediment. It seems like the sediment is sticking to the body of the sponge larva, and because the sponge larva's body is covered by this really short cilia which it uses to swim, what we have been seeing is that it kind of slowed them down in their swimming. At the moment it's very subtle effects, but we'll also see whether it's going to affect their settlement. So that's the next set of experiments that we're going to be looking at.
This room has been set up for culturing crown of thorn starfish, which are a real problem for the reef currently. So one of the hypotheses is that changing land use practices, so introducing more nutrients into the water column, which results in an increase in phytoplankton, which is the food for larvae, which means we get more crown of thorn starfish larvae surviving. So we've created systems that enable us to dose phytoplankton to the crown of thorns larvae to look at their survival and growth and see how that relates to the survival of the crown of thorns in the field.
We have a lot of undiscovered biodiversity, and there's a lot of still outstanding questions about how those marine ecosystems operate. And so to service that need, here at AIMS you also have 2 state-of-the-art research vessels. So we have the RV Solander, which is primarily based in Western Australia. And that does a lot of work offshore from Broome and Dampier and those sort of places. working very collaboratively with the oil and gas industry and also parks and others to help manage those marine resources. That vessel often comes around into the Northern Territory, but on the east coast we have a smaller research vessel, 25 metres long, called the RV Cape Ferguson, and that primarily focuses on the Torres Strait and the Great Barrier Reef. So when you look at our national footprint, our state-of-the-art facilities that we have scattered across the north, and our research vessels, it's quite easy to see how we're very uniquely placed to be able to get our researchers out to these undiscovered parts of the world, to put them in the water, to take actual observations and to record actual conditions which we can then replicate in our aquarium facilities and our experimental facilities, to really get a handle on what's in the marine environment, how it's responding to current environmental change, and what are the future scenarios likely to look like for those ecosystems across Northern Australia.